Hi everybody. So in this video, we're going to be talking about how to actually solve a system of equations with matrices, finally. Okay, and this is just one way to do it. It's not the only way, but it's going to be using inverse matrices. So let's talk about how to find an inverse matrix. That's probably a good place to start. So if we have a 2 by 2 matrix, and we're just going to focus on 2 by 2s for now, okay? If we have a matrix that's a 2 by 2, then the inverse of that matrix exists if the determinant does not equal 0. And the reason for that is if you look at our calculation for the inverse matrix here, the bottom right here is the determinant. So if the determinant was 0, then we would have 1 over 0. It's undefined. We can't have that. So that's why the determinant can't be equal to 0. Okay, so to calculate our inverse matrix, okay, pay attention to the order of the elements here originally. We're going to do 1 over, and then this is really the determinant of A, times, and then notice that A and D have switched positions, and also notice that the signs of B and C have changed. So that is going to be how we calculate our inverse matrix. So let's do it down here for example 1. Okay, so we have a matrix P. We're trying to find the inverse of that. So first, we need to calculate the determinant. Okay, so the determinant of P would be 7 times -1 minus -5 times 2. So -7 plus 10 is equal to 3. Okay, it's not equal to 0, so this tells us, okay, we can actually calculate the inverse of this matrix. So let's do it. Okay, to find P inverse, so the -1 here is how we show it's an inverse. Okay, that will be equal to 1 over the determinant, which we found was 3, times, and then this is where you have to be careful, right, because we're changing some things around. We said that A and D are going to flip spots. So the 7 and -1 here are going to switch positions. And then the 2 and the -5 are going to stay where they are, but they're going to change signs. So it's going to be a -2 and a +5. So now it's just some scalar multiplication, right? We can just multiply everything inside by 1/3. So our inverse matrix is going to be equal to -1/3, 5/3, -2/3, and 7/3. Now, you're probably looking at this and you're not excited about where it's going because we've got some fractions. Okay, it is not uncommon to have fractions, and a lot of them inside of inverse matrices. Okay, so this is our answer for right now. Okay, we were just trying to find the inverse matrix. So let's look at how we can take this and actually do something useful with it. Okay, so let's talk about how to convert a system of equations, and we're just going to do 2 variable, 2 equation systems for right now. Let's talk about how we can, convert this to matrix form. So if I have this matrix here, we can break it into a couple different parts. Okay, we're going to create this matrix A that you see here by just taking all of the coefficients that we see in our system. Okay, so that's what that first matrix represents. Then we're going to have a variable matrix that you see here that's just our x and y. We've got our equal sign still, and then this matrix B represents the constants, so the stuff on the other side of the equal sign, right? So you can probably see where everything's coming from. Now, we're allowed to do this because if I multiplied this matrix A and X back together, right, we know how to multiply matrices together, we would get X plus 2y and 3x minus 6y. So that's why we're allowed to, break it into pieces like that. But what we're trying to do here is we're really trying to get this matrix X, right, the one that has the variables in it, we're trying to get it by itself. So if we're just thinking about this as an equation, right, A times X equals B, we know that we would have to cancel the A off of the left side to get that X by itself. And we can't divide with the matrices here. So the way that we talk about it is I would need to multiply matrix A by its inverse. If I multiply something by its inverse, it cancels out, it creates a 1. So then I would have to do that to the other side as well. So this is where our inverse matrix comes into play, right? We're saying that I can find matrix X, which are my X and Y variables. I can find what those are equal to by doing the inverse of matrix A times matrix B. So let's do an example of this, right? Let's see what happens. So the first thing that we need to do is we need to change this system into a matrix. So we're going to have our coefficient matrix, right? 2, 1, 3, 2. We're going to call that matrix A. And that's multiplied by our variable matrix. So matrix X, and that should be equal to the constants, which we said we're calling matrix B. So we know that we should be able to find X and Y if I multiply the inverse of A times matrix B. So let's find the inverse of A. Okay, and to do that, we need to find the determinant of A first. So the determinant of A would be 2 times 2, which is 4, minus 1 times 3, which is 3. So the determinant here, very conveniently, is a 1. So that means, okay, we're allowed to calculate the inverse. Remember, we said if the determinant does not equal 0, then the inverse of that matrix exists. So now we can actually find the inverse. Okay, the inverse of A is going to be 1 over the determinant, which was 1, times, right? And then we said that the A and D values are going to change. In this case, they were both 2s, so it doesn't make a difference. And then the 1 and the 3 are going to change sign. So our inverse matrix here is 2, -1, -3, 2. So now we've kind of done all of the setup here. Okay, we're ready to actually solve. So remember, our big idea was the X matrix, right, with the X and Y variables, is equal to the inverse of A times B. So we need to set up this calculation or this equation now. Okay, so X, which is really, let's write it as a matrix, XY, is equal to the inverse of A, which is 2, -1, -3, 2, times matrix B, which is 0, -2. So now this boils down to us just multiplying two matrices together. Okay, XY, we'll just work down here, is equal to, and then if we multiply this 2 by 2 matrix with a 2 by 1, the result is going to be a 2 by 1 matrix. So we need to take this row times the column here. So 2 times 0 is 0, plus -1 times -2 is 2. And then to find the bottom row, we need to take the second row here and multiply it with that column. -3 times 0 is 0, plus 2 times -2 is a -4. So we find XY, okay, that matrix, is equal to 2, -4. So you can see here, if we're just looking at what corresponds, this matrix at the end tells us our solution is an X value of 2 and a Y value of -4. So our solution to the original system of equations is 2, -4. All right, we will be talking a lot more about this, okay, but this is the main idea, okay? Calculate the determinant to determine if you can find the matrix, find the inverse matrix, and then we can set up some matrix equations to solve for X and Y. So that is it for this video. Have a wonderful rest of your day.